Good afternoon, everybody, and welcome back. So we're really excited here to continue our session on innovations in electronic monitoring and electronic reporting. We've got a lot of great presentations this afternoon, and we're going to kick things off with Chris Moeseneder from CSIRO, who's going to be talking about his project harvesting radar data from vessels. So Chris Moeseneder is the data manager and programmer for radar data and SAR processing for illegal, unreported, and unregulated fishing. So please, everyone, welcome Chris to the stage.
Thank you, Mark. Hi, everyone. My talk is on RadarTrac, the low-cost radar and AIS harvesting system that we've invented. This is the team of people that are behind the development. We've got Dr. Hardesty, who's the lead on the project, Dr. Iskowitz, he's a modeler and statistician, Dr. Wilcox, who was the initiator of the idea and who's now with Minderoo, and Dr. Leslie Robertson, my brilliant colleague on this project. She's much more than what it says here. She's also now a radar specialist, and I hope that you saw her talk in the other room on AIS in the morning. Monitoring vessels at sea is a big challenge, and that's the case for governments even, especially so for nations that have a large marine area and in areas where there are many vessels, small vessels that have any kind of transponder system. For example, Indonesia has a fishing fleet of 500,000 vessels, and only 0.5% of these would qualify for AIS. There are, of course, existing observation systems such as satellite data, but these are usually prohibitively expensive, and they often fail to detect the small vessels that don't have VMS or AIS. And then integration into processes is another issue, so that you can achieve meaningful results and have a good return on investment. Onboard harvesting is sensible because it makes available data for the area that you're harvesting at. We did not find any off-the-shelf commercial systems that would do radar harvesting. I'm not saying that there are none. We did not find any when we started with this. So we've developed a low-cost system that utilizes ships' existing navigation radar and the AIS transponder. RadarTrac is built from commercially available hardware components. We run Furuno's Time Zero software, which in itself has 70,000 installations already. I've talked to a few of you. I know that the software is well known. We connect to vessels' instruments via the multiplexer. That's the orange unit in the middle there. And it's a small component stack that is mounted in the vessel's electronics bay. RadarTrac meets all the requirements for safety at sea for big vessels, as imposed by Lloyd's Register and the IMO, but we are not LR or IMO certified because we just don't have the production that's required for that. We have small-scale production at the moment. RadarTrac can be installed on any size vessel. We like ones that are continuously at sea. It's compatible with Furuno FAR and DRS systems, and we use the vessel's internet connection to transfer our data. It wasn't a linear process to get to RadarTrac. We began with a microcomputer system that's called Raspberry Pi. It's based on the Raspberry Pi, and we first harvested radar targets and then found AIS to be very simple, to be a byproduct of that. In the middle, the white box is the microcomputer. At the top, you see the little remote control and some status light there. On the left-hand side is the modem that we use to transfer data and the multiplexer where we receive data from the ship's instruments. And you can see it integrated on a vessel's bridge in the electronics bay over there on the right. We trialed the system over more than 2 years on 13 vessels. They're ranged in sizes from small yachts to larger ones. We had 3 installations with the Indonesian Directorate General of Fisheries on their patrol vessels. But we did identify that there was a need for redesign. We thought we could install the system on a large number of boats. That was not the case because all the vessels are a bit different, and installation was non-trivial, as we found out. There are always changes in technology on board those vessels, even if it's just the Wi-Fi password. So things become difficult sometimes. And radar harvesting has its particularities, but I'll get to that in a moment. We also found that the lowest equipment cost was not the best solution, which I suppose makes sense, but we had to learn it the hard way. The microcomputer system was at about $700 US dollars per unit. RadarTrac is at about 4,000, but the data captured by RadarTrac is much better quality, and we're now working on the metric of price per valid harvested data point. So RadarTrac saves data from the host ship's navigation radar and AIS receiver. We get those images directly from the radar, and we bypass the navigation critical devices, so we don't interfere with those. We use the ship's communication system to transmit our data, and when the data is received on our server or on the cloud, we process the data and analyze it, and then make it available for partners' requirements. This process here in graphical form, the two antenna, one, the radar, the GPS and AIS receivers that pass data to the RadarTrac stack, goes to the server, to the cloud. We make it available to partners. Here we see two vessels. Both are being picked up by the radar, but only one is being picked up via AIS because the other one is a non-transponding vessel. We harvest all the targets in a radar's range. We use S-band or X-band, and we do a full resolution sampling, which is about a 2-second sweep, so we get the targets every 2 seconds. Targets are identified by their target ID, and you can see some real-world data here from some of our harvesting efforts. When we compare RadarTrac to other systems, radar targets are then compared to AIS data by distance, speed, and time. We use a couple of algorithms to see where dark vessels might be. We, of course, then find the non-transponding ones, the ones that only use radar, and we predict the vessel presence and trajectory and activity over space and time. We use a Kalman filter, which is fairly common for position prediction, and we also have in development at the moment a better covert behavior analysis that works with the birth and death, as we call it, of targets. RadarTrac is different from other vessel monitoring systems like VMS, satellite AMS, and cameras because the focus is not on the host ship. The focus is on detecting targets that are within the ship's radar range. We only use the position of the boat to calculate those target positions. We're not interested in that data otherwise, and therefore it's also very difficult to determine what the harvesting vessel was. Essentially, we've built an outward-facing voyage data recorder. Our first goal in development was, of course, to ensure safe operation on the vessel, to be autonomous from the ship and the crew, so they have nothing to do with it at all. We did not want any effort to be expended by the partner, and then only as a fourth item, we're trying to harvest the maximum number of targets possible. It wasn't a linear process. We learned a few things on the way. One was that we tried to capture targets as crew captures them on the boat, and we found that was very rarely used. We then tried ARPA auto capture on the main screen, and that tended to interfere with navigation. The next try was ARPA auto capture on a secondary screen, and that just produced too much clutter. We have two data products that comes from this data stream. We can quantify vessel presence, distribution, activity over periods of time. You'll see Sumatra over here with some real data of what we've harvested. And the second stream is real-time surveillance, where we use the vessel's satellite internet connection to transmit data. We run the algorithm directly on the incoming data, and this is an application that's, of course, sensible for marine protected areas, for enforcement. We're trying to provide this data stream to partners via an API in under a minute. And of course, I think like everybody else, we're going to be trying to utilize Starlink where it's economically feasible. Benefits to partners, of course, this helps fill an important gap in the current vessel monitoring network. Partners get long-term vessel statistics. They get this additional data stream that can help them make decisions in surveillance operations. And of course, finally, it's also a contribution to better ocean governance. I have RadarTrac with me, one unit, and I have the little microcomputer system with me also. And if you'd like to see it, I will happily show it to you. And Leslie Robertson is also here to talk to you if you're interested. Thank you.